Hello, welcome, and thank you for zooming into the void for the month of March in the year 2021, presented by our good friends at Danakid Associates. I'm Ben Wright. I will be your host for our tour of the sky for the month of March. I'm also one of the resident astronomers here at the Danville Science Center. As always, our virtual online interstellar discussion is interactive. If you have any questions or comments that arise throughout our tour, feel free to submit them to me. If you're doing that in Zoom, you can do that directly using the chat with host feature there within the Zoom client. And if you are watching via Facebook, you can submit your comments or submit your questions in a post directly below this live feed. Let's go ahead and dive into discovery. We begin, as we always do, outside of the Digital Dome Theater in the backyard of the Danville Science Center. We are facing the southern sky, which means to our left is the east, to our right is the west, and directly behind us is north. It is just a few minutes past noon on the 9th of March, 2021, and looking skyward, we can see our central star, the sun, is shining brightly down on the museum at a position nearly directly overhead from our viewing. The closest the sun will get to directly overhead is still 11 days from now. This occurs when the ecliptic, the apparent daily trajectory of the sun, intersects the equator, the imaginary line that divides our planet in half on the horizon. On that date, when the two intersect, when that happens, which will be not on the 9th, but on the 20th, there they are intersecting. When that happens, we will experience roughly equal amounts of daylight and darkness in what scientists call an equinox, meaning equal dark. For the northern hemisphere, that's our part of the Earth, March's equinox marks a period of increasing solar exposure, resulting in longer, warmer days that encourage growth in new life. The official celestial start of spring. If we return back to today, but just after the sun sets, we can spot the celebrity, our focus of last month's void. And we get the aid for looking for that by looking at a couple of other bright lights that we can see in tonight's sky. We begin by finding the brightest star in the night sky, Sirius, which is joined by its fellow dog star, Procyon. We continue moving our eyes to the right, and we can find two other bright stars within the constellation Orion, Regal, and giant Betelgeuse. It'd be acceptable if you mistook Betelgeuse for another bright reddish orange star, the fiery red eye of Taurus the Bull, the star known as Aldebaran. Finding all these bright stars brings us to our final brightest red orangish light, which is what we're focused on, the planet Mars. Last month, we again focused on Mars and the landing of NASA's newest planetary exploring robot, the Perseverance rover. Perseverance has already sent back video, sound, and tweets from the Martian surface and will continue to do so for at least the next Martian year, which lasts 687 Earth days. Streaming the best footage here would not do it justice, but after our tour, I highly recommend heading to NASA's YouTube channel for high-resolution footage of humanity's next steps in placing feet on another planet. Be sure the video is from NASA, or the Jet Propulsion Laboratory, as unfortunately, there is some less than credible footage out there already. This month is an excellent one for spotting planets in general. Though we couldn't see it from our location, the Moon and Saturn made a close approach this evening, placing them at conjunction. When the Moon again rises above the horizon in the pre-dawn hours of tomorrow morning, it will be in conjunction with the planets Mercury and Jupiter. On the 29th, Mercury and Neptune will reach conjunction. Given so much activity, it is a good time to take a closer look at the outer planets. The four furthest planets from the Sun, Jupiter, Saturn, Uranus, and Neptune, are called the outer planets due to their being separated from the four inner planets by the main asteroid belt, a span of space between Mars and Jupiter where the majority of asteroids in our solar system can be found. Also, the four largest planets in our system, they can be split further into two categories, the gas and ice giants. The first gas giant is the largest of the large. Jupiter has a diameter that is more than 11 times that of Earth. If we combined all the other planets into one, Jupiter would still have more than twice the volume of that collection. Its large size results in the planet having strong gravitational pull. Jupiter has over 70 supposed moons that orbit it, second only to Saturn for most natural satellites. The four most famous are also the four largest, each observable with the most basic telescope. Observable with the first telescope, actually, thus the reason for their being named the Galilean moons. Italian astronomer and inventor of the telescope, Galileo Galilei, first spotted these moons over 400 years ago. Jupiter may contain a solid core, but its surface is a collection of swirling gas clouds that give the planet its band appearance. A day on Jupiter lasts just under 10 Earth hours, the fastest of spin of any planet in our system. This rapid rotation combined with a mainly gaseous composition results in some pretty extreme weather. Jupiter is a very windy planet that experiences lightning storms at its poles. One of Jupiter's most distinguished features, however, is a massive hurricane-like storm that has been observed for over 350 years. The Great Red Spot is a high-pressure anticyclonic system in Jupiter's atmosphere that spans the width of 3 Earths. Winds in the Great Red Spot can exceed speeds of 268 miles per hour. Not one to be left out, Saturn also has a massive reoccurring storm, but this one does take breaks. Every 20 to 30 Earth years, Saturn experiences a planet-encircling massive thunderstorm known as the Great White Spot. Unlike Jupiter's storm, this one has high activity at its center with long winding tails of lightning. You can see it from Earth using a telescope. The most recent discovery of the Great White Spot occurred in December 2010. It lasted for nearly 2/3 of an Earth year and eventually wrapped itself completely around Saturn. 20 to 30 Earth years may seem like a long time, but that is how long it takes Saturn to make one trip around the sun, making this a yearly occurrence. Saturn has an axial tilt of 27 degrees, so it does experience seasons. However, its lengthy orbital period means seasons on Saturn last more than 7 Earth years. It is also a gas giant composed mainly of hydrogen and helium. Its core has a temperature of over 21,000 degrees Fahrenheit, resulting in it radiating out more heat energy than it absorbs from the sun. Easily Saturn's most recognizable feature is its distinctive series of rings composed of ice, dust, and rock. These rings extend between 4 and 100,000 miles outward from Saturn's equator. Galileo is recorded as the first person to discover these rings, again using his early telescope. Uranus also has observable rings. In fact, all of the outer planets have rings, just Saturn and Uranus's are the most easily viewed. The rings around our first ice giant orbit it vertically rather than horizontally. Earth tilts on its axis at 23.5 degrees. Uranus is tilted at 97 degrees. It is the only planet whose equator is nearly perpendicular to its orbit. As such, the planet can appear to be rotating on its side. Its clockwise rotation is also in the opposite direction of all the other planets except for Venus. Uranus's color comes from being covered in layers of frozen methane, ammonia, and water. At 2 billion miles away from the sun, temperatures on Uranus can reach negative 364 degrees Fahrenheit. 80% of the planet is covered with icy material. William Herschel, who first discovered Uranus, wanted to name it Georgium Sidus after King George III. Instead, it is named for the Greek god of the sky. Named for the Roman god of the sea, Neptune is also a very cold frozen planet. It also gets its distinctive blue color from methane in its atmosphere. Neptune is the windiest planet in our system, with frozen methane clouds being pushed around at speeds of 1,200 miles per hour. Winds on Earth rarely exceed 250 miles per hour. A group of white clouds, referred to as the scooter, race around the planet every 16 hours. At more than 30 times farther away from the sun than the Earth is, it takes sunlight over 4 hours to reach Neptune. The gas giants can be spotted early tomorrow morning, just before sunrise, about half an hour before sunrise. So if we fast forward to then, just a little bit after 6, or rather a little bit before 6, and we will look low in the southeast, just above the horizon. So we'll get rid of those buildings. Here is our horizon line, and just above it, we can spot some of these objects with the aid of our moon. The brightest object, of course, that you will see is the moon. All of these are in the constellation Capricornus, the sea goat. The moon will be at 9% illumination in a waning crescent moon. If you continue your eyes up and to the left, the next brightest object you'll see is the gas giant Jupiter. And then up and to the right, you can see the gas giant Saturn. Also visible will be the closest planet to the sun, Mercury. We can spot all those early in the morning tomorrow with the aid of our moon, again at 9% illumination. Our next chance to view a fully illuminated moon will occur exactly at 2:48 p.m. on March 28th. A fully illuminated moon lasts only a few seconds, but the moon can appear full 3 to 4 days following such an occurrence. The first full moon in March is known as a worm moon, named for the spring thawing of the ground resulting in the reappearance of earthworms. The first full moon of spring is also known as the Paschal Moon, as it sets the date for Easter as the first Sunday to follow the occurrence. The first movable feast of Easter is always the first Sunday after the first full moon of spring. My wife has been sick and my kid is grown, so I don't know that we will be dyeing eggs this year, but we certainly will be celebrating the return of life once thought lost. Want to know more about Easter? Perhaps want to know about the dwarf planet that was temporarily named the Easter Bunny. Do you have any fun Easter traditions? Now is your chance to share them. Any questions or comments you may have. Again, if you're joining us via Zoom, you can post them, send them to me using the chat with host feature there within Zoom. If you're joining us via Facebook, then you can post it. You can submit your comments in a post directly below this feed. And now is the time where I will attempt to go and respond to some of those. Our first question comes from Tina. Tina asks, how long does it take sunlight to reach Earth? Again, it can take over 4 hours to reach Neptune. Here on Earth, it's not instant. We don't get that sunlight immediately. It takes a full 8 minutes for light to travel from our central star to our planet. That means anytime we see an image of the sun, no, we do not look directly at the sun, but you can use special filters to look at it with a telescope. That light is 8 minutes old, meaning anything we see actually happened 8 minutes prior. We can look into the past just by using our sunlight. So yeah, it takes 8 minutes for sunlight to get to Earth. Gene asks, so which is the Easter Bunny planet? Easter Bunny planet is one of the dwarf planets. There, you may remember from a previous void, we talked about the 5 fully recognized dwarf planets that exist past Neptune. For the most part, those include Pluto, purely demoted Pluto, Ceres, Aries, Haumea, and the one in question, Maki Maki. Maki Maki was discovered in March, around the time of Easter several years ago, I think in 2005. And that's the reason why temporarily, before they had an official name for it, they called it the Easter Bunny, because again, it was found during March. Even now, Maki Maki is actually the name of a deity, the creation god for some of the indigenous folks in the Easter Islands. So again, it's got that tie to Easter with its name, again, Maki Maki. Bob asks, what are the Galilean moons? So the Galilean moons are 4 of the biggest moons of Jupiter. And again, they're called that because they were observable with a telescope by Galileo. The 4 are the largest moon in our solar system, Ganymede. The second largest around Saturn, but not the second largest in our system, which is Callisto, which is also covered with craters because it lacks an atmosphere similar to our moon. There is the frozen ice giant Europa, which is another spot where scientists are really interested in looking for life, as Europa contains potentially flowing oceans underneath a thick layer of ice, and Io, which is covered with volcanoes. It is the most seismically active spot in our solar system. It's volcanoes everywhere due to plate tectonics and all that fun stuff. So those are the 4 Galilean moons: Ganymede, Callisto, Io, and Europa. Louise asks, how old is your kid? My stepson is 22 years old. His mother's a little bit older than I am. So if you're trying to do the math, that's the deal. I met him when he was 13, 14, so I don't have a lot of egg dyeing experience with him, and I don't imagine that I'll be gaining some anytime soon. Bonus fun egg fact, haha, there is an egg-shaped planet, but it is an exoplanet. Exo meaning that it is external to our solar system. This planet does not orbit our sun, but orbits a whole different star and a whole nother system, thus exoplanet. The exoplanet WASP 12b, or WASP 12b, is egg-shaped, meaning that it sort of bulges out at its sides rather than being more spherical like Earth is. The reason being is that it spins really, really, really fast on its axis, so much so that its mass sort of bulges, or at least that's the theory, that its mass has caused it to bulge out, looking like an egg. Whatever your Easter traditions, even if you don't study Easter, I hope you spend a good portion of March looking into the night sky, viewing some of our planets, stars, and other fun objects that can be seen up there. We appreciate you taking the time to spend some time viewing the sky with us in this month's discussion. We hope that you join us again next month, the second Tuesday of April, April 13th, when we will again be zooming into the void with collaboration from our friends at Danakey Associates. Again, we're so glad you joined us. Until that time, we hope that you stay safe, stay healthy, and as always, stay curious. Thank you, and goodbye.